All right, so in chapter 6, section 2, we're going to talk about binomial probabilities. Again, there's two things that can occur in a binomial probability. So I just wanted to first show you how StatCrunch can find these values for you. So if you know that you have a sample size of 12, the probability is 70%, and you want to find out to make exactly 10. Let's put this in free throws. You're going to make 12 free throws. You're a 70% shooter, and you want to find the probability that you make exactly 10. So in StatCrunch, we're going to go back to the calculator, but the binomial calculator. And now we can just type in our information. Super easy. So we have a sample size of 12. We are a 70% free throw shooter. And I want to find the probability I make exactly 10. And it gives me the value, 0.1678. So 0.1678. And so using StatCrunch to find these things for us is super easy. The actual calculation by hand, we use some of those combinations and permutations from the previous chapter. A little bit more extensive because we've got to think about all the different ways we could have made 10 shots out of the 12. But again, StatCrunch does a great job showing us how to do this. Another one to look at, number 14, is finding the mean and standard deviation of a binomial model. So if you're looking at this, there's formulas in the book, but the mean of a binomial is looking at the percentage times the number of people. So if 60% of adult smokers or smokers started before they're turning 18, and we had 100 trials, right? So we would expect 60 of them, right? It's your mean is your percentage, your P, times your N. So that's one of the formulas. We can look at the textbook, and it'll show us these formulas in chapter 6, section 2. So, let's see if those are on the next page. One more page. Oh, this is number 14, sorry. We're getting there. Well, let's go back and look at this. Some of those calculations you would have to do to use that, what the binomial calculator does for us very nicely. But here's our formulas. So the mean is n times p, and the standard deviation is the square root of n times p times 1 minus p, sometimes called q in different books. So again, back to our problem. It's just multiplying n times p. So 100 is our n times 0.60. So our mean would be 60. And our standard deviation would have to use that other formula. So it's the square root of n times p times, they put it as 1 minus p. And we can do that. I kind of look at it as n times p times q, where q is 1 minus p. Either way, it works out fine. And so we get the standard deviation to 1 decimal place is 4.9. So we have a nice way of calculating the mean and standard deviation of a binomial probability. And then they ask us to interpret the mean. Would it be unusual to observe 80 smokers? Again, thinking about the empirical rule from chapter 3. Um, was that chapter 4? I think it was chapter 3. 2 standard deviations above is 70. So we're 4 standard deviations above to get to 80. That seems pretty unlikely. Um, but again, I'll let y'all do some research on that. In your readings, you should find some information to determine if it's unusual or not.